I've entitled this a photo of Lalande21185. Now, let's see where this actually comes from. So let us have a look at a list of the nearest stars. What do we see on that list? What would be worth a look on the list here? Well, where do we start? The Sun, the nearest star. Magnitude minus 26.74. Well, we see the Sun in the daytime, sometimes. It's not what we could call a challenging object to see. Okay, next nearest star. The Alpha Centauri system, including Proxima Centauri. Well, we do see those are way in the southern part of the sky. So, that's not easy. Next one, Barnard star. Okay, it's north of the equator. Magnitude 9.5. Okay, it's not too faint, but it is somewhat of a challenging object. Then we do get a double brown dwarf system and another brown dwarf. Whether those actually count as stars that's a moot point there. Wolf 359. Okay, the problem is magnitude 13 and a bit. What's next? Lalande21185. Magnitude 7.47. That's not that far below naked eye visibility. Declination plus 38. It's in the northern sky. And we see it's nearer than Sirius. So if we want to find something of a challenge, an acceptable challenge in the nearby stars, let's go for Lalande21185. Here we see the position of Lalande21185. We have the stars of Leo Minor over here. We have Ursa Major here. We are between Leo and the Plough. Okay, so the camera that I was going to use for this purpose, digital SLR, 75mm lens here, and here's the mount that it would be placed on. It's a driven mount, driven around an axis that can be pointed at the pole. And, well, in many ways the polar alignment is one of the more difficult parts of the process. It is a case of looking through the little telescope that exists in the lower part of the mount here and adjusting the screws for azimuth and altitude until you're able to see the pole star easily through this finder. Now, it is a case of not putting the pole star at the center. There is a circle that it can be used for this purpose to get the pole star on the circle at the right place in the circle, so that it is the appropriate, it is the actual north pole of the sky, which is in the center of the field of view of this little finder scope that determines the polar axis. Okay, so the observation took place around here. This area, well, currently only able to go outside here once a day, and only that for exercise, but let's move away from that. It was a couple of days previously that this had happened, that this observation took place. You can see, yes, there's various pieces of vegetation around, but perhaps more of a worry, this and this. Those do cast their bit of light pollution. But, the particular location avoided the worst of them. It wasn't as if the camera was pointing straight at any of the streetlights. So then, the process of the photography took place. There were actually 20 images that were taken. Each of those was a 1-minute exposure. ISO was 200, so you're noticing I'm not going for the quicker settings, taking a little bit longer, but hopefully as a result of that getting a bit more resolution. And here F10. So not opening the lens as much as it could be done, taking care of course for the focus. There were 20 images there, but there were also 5 dark images which were taken in exactly the same way, but committing what seems to be the ultimate crime of leaving the lens cap on. But they're there as a comparison. And we also have 20 offsets which are actually 1/4000th of a second. Again, it's a case of comparing the very short files with the actual files. And of course, all this is done within the Deep Sky Stacker software. Now, if we look at the single pictures that come out there, then yes, if we look hard enough, we can see, a few stars around here. But that's a single picture that had gone in. But instead, well, this is the kind of setting that you have to play with on Deep Sky Stacker once you've given it all the information about the various pictures that you're processing. You can change various things, including the colour, although I keep all the colours together, and just try and get things at the moment that the curve here starts to go up. If you're a bit more greedy and take it further here, you find that the background gets brightened as well. So what's the result? This was the result. And here we have a photograph of the area of sky, including Lalande21185. So putting in a few of the names here, we can see some of the stars in Leo Minor. The red and the green ones, well, ones circled in red and green, are from Leo Minor. Magnitude 3.7, 4.6, and then the stars over towards the left, those are actually in Ursa Major, magnitude 5, 5.8, a brighter one here, 3.4. But this is the object of interest. You'll remember this equilateral triangle almost from the stellarium view. So here we have it. This is Lalande21185. Back to the actual image here. Here it is. This is Lalande21185. It is the brightest red dwarf star in the northern hemisphere, and it is also the nearest easy binocular star in the northern hemisphere.